Earlier this month, astronomers captured the world's attention with the announcement of a truly rare cosmic visitor, a mysterious object now known as 3I/Atlas, confirmed to have originated from outside our solar system and currently racing toward its inner regions at extraordinary speed. Interstellar objects like this are exceptionally uncommon. In fact, 3I/Atlas is only the third such object ever conclusively identified, following the famous Oumuamua detected in 2017 and 2I/Borisov observed in 2019. Each of these discoveries has pushed the boundaries of modern astronomy, forcing scientists to rethink long-held assumptions about how common interstellar debris might be and what secrets such objects could carry from distant star systems. With limited time to observe 3I/Atlas before it speeds past and disappears back into interstellar space, researchers around the world are scrambling to gather as much data as possible, using ground-based telescopes and advanced modeling techniques to understand its composition, motion, and origin. At first glance, the most straightforward explanations for 3I/Atlas are entirely natural. Mainstream scientists suggest that it is either a comet or an asteroid that was ejected from its parent star system millions or even billions of years ago, wandering through the galaxy until a chance gravitational encounter sent it into our cosmic neighborhood. This process is thought to be relatively common on a galactic scale, as young planetary systems are often chaotic, flinging debris into deep space during their formation. Yet what has sparked intense debate is not merely the object's interstellar origin, but a combination of unusual characteristics that seem, at least superficially, difficult to explain with conventional models. Its trajectory, velocity, and apparent behavior have prompted some astronomers to raise provocative questions, including one that sits at the fringes of scientific discourse. Could 3I/Atlas be artificial in nature? One of the most vocal proponents of this idea is Harvard astrophysicist Avi Loeb, a figure already well known for challenging orthodox interpretations of cosmic phenomena. Loeb previously gained global attention by arguing that Oumuamua might have been an artificial object, possibly a piece of alien technology rather than a natural space rock. In the case of 3I/Atlas, Loeb and his collaborators explored a similarly speculative possibility in a paper that has not yet undergone peer review. In this work, they examined whether the object's unusual orbital path could be consistent with deliberate maneuvering, including what Loeb described as potential attempts to slow down or brake as it approaches the vicinity of Earth and Jupiter. Such behavior, if confirmed, would be difficult to reconcile with a simple inert comet or asteroid and would raise profound questions about the existence of extraterrestrial intelligence. However, even Loeb himself has been careful to emphasize caution. The paper explicitly states that the alien technology hypothesis is not a conclusion, but rather an intellectual exercise designed to explore all plausible interpretations of the data. The authors stress that the strange combination of orbital parameters could easily be the result of coincidence, observational limitations, or incomplete understanding of the physics governing interstellar objects. They repeatedly underscore that the most likely explanation remains a natural one, probably an interstellar comet composed of ice, dust, and rock. In this sense, the paper functions less as a declaration and more as a reminder that science progresses by questioning assumptions, even when those questions make people uncomfortable. The debate has drawn in other scientists who approach the issue from a more conservative but still open-minded perspective. Sarah Webb, a lecturer at Swinburne University of Technology, has argued that while the idea of an alien probe may sound sensational, it should not be dismissed outright simply because it challenges our expectations. Writing for The Conversation, Webb pointed out that humanity itself has already launched objects into interstellar space. The Voyager 1 and Voyager 2 spacecraft, sent into space in the 1970s, have officially left the heliosphere and are now drifting through the space between the stars, carrying with them golden records intended as messages to any intelligent beings that might encounter them. Pioneer 10 and 11 are not far behind. Given this precedent, Webb suggests it is not unreasonable to imagine that an advanced extraterrestrial civilization, if it exists, could have deployed similar exploratory probes long ago. This line of reasoning reframes the alien probe hypothesis not as science fiction, but as an extension of known technological behavior. If humans, a relatively young technological species, have already begun scattering artifacts beyond our solar system, then a civilization millions of years more advanced could conceivably have filled the galaxy with autonomous explorers. These probes might be designed to observe planetary systems, collect data, or even remain dormant for eons until they pass near a star like our Sun. From this perspective, the idea that one such object might pass through our solar system is not inherently absurd, even if the probability remains extremely low. Despite the intrigue, determining whether 3I/Atlas is artificial or natural is extraordinarily challenging. Webb notes that the first step would be to look for features typical of comets, such as a visible tail or coma produced when sunlight heats volatile materials, causing them to vaporize. The presence of such features would strongly support a natural origin. Beyond that, scientists could search for more subtle indicators, including unusual light curves that might suggest a non-natural shape, or signs of electrostatic discharge resulting from sunlight interacting with metallic surfaces. Radio astronomers could also listen for any form of electromagnetic emission that might hint at communication or onboard systems, though the absence of such signals would not definitively rule out artificiality. Complicating matters further is the fact that interstellar objects travel incredibly fast relative to the Sun, giving astronomers only a narrow window in which to observe them. By the time enough data is gathered to form robust conclusions, the object may already be on its way out of the solar system, beyond the reach of our instruments. This limitation means that many questions about 3I/Atlas may remain unanswered, leaving room for speculation but also frustration within the scientific community. Ultimately, both Webb and Loeb converge on a similar conclusion, despite their willingness to entertain unconventional ideas. In the absence of clear, unambiguous evidence of artificial origin, the safest and most scientifically responsible assumption is that 3I/Atlas is a natural interstellar object. Most likely, it is an ancient, icy body that formed around another star long before the Sun existed, carrying within it a record of chemical processes from a distant part of the galaxy. Its extreme speed and unusual trajectory may reflect the chaotic gravitational interactions that shaped its journey rather than any deliberate intent. Yet even if 3I/Atlas turns out to be just a comet, its significance should not be underestimated. Each interstellar visitor offers a rare opportunity to study material formed under entirely different cosmic conditions, potentially shedding light on how common the building blocks of planets and life might be throughout the galaxy. Moreover, the debate surrounding its nature serves a broader purpose. It forces scientists to refine their observational techniques, improve theoretical models, and confront the limits of their assumptions. In that sense, 3I/Atlas functions as a kind of cosmic mirror, reflecting not only the mysteries of the universe, but also humanity's enduring curiosity and willingness to ask profound questions about its place within it. For now, 3I/Atlas remains an enigma hurtling silently through space, its true nature still unresolved. Whether it is an unremarkable comet or something far more extraordinary, its passage through our solar system reminds us that the universe is vast, dynamic, and filled with surprises. As our instruments grow more powerful and our methods more sophisticated, future interstellar visitors may provide clearer answers. Until then, 3I/Atlas stands as both a scientific puzzle and a powerful symbol of the unknown, challenging us to observe carefully, think critically, and remain open to possibilities that extend beyond the familiar.